This is the video for Unit 7, Lesson 5, Exponential Equations, using the one-to-one property. So the goal is going to be, we're going to be introducing solving an exponential equation, so essentially doing the inverse of what we did with solving logs, and this is going to be using the one-to-one property. So our goal today is going to be solving exponential equations, and we're going to be having to review some of our exponent properties that we learned back in Math 1 in like 8th grade. So just a reminder, we're going to see today the product property. So if I'm multiplying two like bases, I can just simply add their exponents. So this is the same as 5 to the 3 plus 7, or 5 to the 10th. We're also going to see the quotient property or division for exponents. So dividing is essentially the same as subtracting. And so we would have 5 to the negative 4 or 1 over 5 to the 4th. We also are going to see the power to a power. So if I have an exponent, a base and an exponent, and it's raised to an exponent, that's the same as multiplying our exponents. So that'd be 5 to the 21. And then obviously, like we already saw with the negative exponent, it's the same as making the exponent positive and doing the reciprocal. And finally, anything raised to the 0 is 1. So we're going to see some of this come up today. There's obviously multiple ways to solve these, but this is a good review for the SAT because you could potentially see a problem where you might have to rewrite an expression using an exponent. So the first thing we're going to see here is we're talking about exponential equations, and if we can simplify, we want to. So on the left-hand side, I'm multiplying two like bases. They're both a base of 3. So if I simplify, I have a 3 to the k plus 2. So I'm adding those exponents. Notice I didn't make it into a 9. I still kept it as a 3. And we have 3 to the 2k plus 2. I'm setting that equal to 3 to the 5k minus 1. And since both of these equal or have the same base, it's like if I was to take the log base 3 of each side. We wouldn't actually, have to do that. Really what this property says is if two bases are the same and you have that, either being set equal, it's the same as setting their exponents equal to each other. So when I, simplify, I'm going to get 2k plus 2 equals 5k minus 1. And then just simply solve for k. So I could subtract 2. And this is now just a linear equation. And add 1 and divide. And so we would get our k to be 1. And that would be our final answer. So if we're able to rewrite a value with an exponent or to set them equal if they're already the same, we want to do that. It ends up being a little simpler. The next one you can see on the right side, I have a base of 2, and I have 2m to the raised to the 2m minus 9. The left side, I don't have a base of 2, but I could actually see if I could rewrite this. So 32 actually could be rewritten as 2 to the 5th. So 2 times 2 times 2 times 2 times 2. And so now I have 2 to the 5th, and then 2 to the 2m minus 9. And so now I could essentially, it's like I'm taking the log of each side or just setting their exponents equal. So 5 equals 2m minus 9, and now I can solve this out. And we would get this to be 7. So m would be 7. For number 3, again, same idea. I'm going to rewrite this if I can. So I have a base of 5. 25, I could actually rewrite with a base of 5. So this is 5 to the 3x plus 1. 25 is actually 5 to the 2nd, and I still have this x minus 2, so there's going to be some multiplication. And then it's like I'm essentially setting the exponents equal to each other. So I'm doing like log base 5 to each side. And now I can go ahead and solve. So 3x plus 1 equals 2 to the x minus 2. And distribute. So I have 3x plus 1 equals 2x minus 4, and then I'm going to solve. So I have x plus 1 equals negative 4, and then I'm going to solve it out and get negative 5. All right. For the last one, same idea. So it's kind of building what we saw in the previous problems. I'm going to see if I can rewrite this as one term. We can. They both have a base of 9. So if I'm multiplying like bases, it's like I'm doing 2x plus 4 plus 3x. So 9 to the 5x plus 4. And then on the other side, I have 1 over 81. So I'm going to see if can I rewrite this with a base of 9. I actually can. So 9 squared is 81. And if it's 1 over 81, that means it's actually a negative, right? Because 181 is the same as 9 to the negative 2. So now I have like bases. I'm going to go ahead and take the log of each side. But again, you can just simply set them equal. And now I'm going to go ahead and solve. So when we solve this out, we get 5x equals negative 6. And negative 6/5, or negative 1.2 would be my final answer. If you have any questions, you can ask in class, sign up for T-Bolt time, or go to the center.